Looking at this problem, we can see that the table that they've given us is a table of values for the velocity of a particle. And what they want us to do is, based upon that table of velocity data, they want us to find out which of the graphs down below is the graph of that original function, the position function. Here's where they really want you to know this physics relationship stuff. So you've got to know this like the back of your hand. So what we know is if the original function is the position function, then the derivative of position is equal to velocity. And so what this is telling us right now is up in our table up above here, we are being given first derivative data. Our velocity table is really first derivative data about our position graph. And so to remember what our derivatives mean, whenever we've got a positive derivative, that tells us where our graph would be headed up and increasing. Wherever we have a negative derivative, that's where our graph would be headed down and decreasing. And whenever we have a zero derivative, that's where our graph is going horizontal. We can usually see those at maxes and mins, but you can also see it when the graph just goes sideways for a second. So what we want to be able to do is go back to this velocity graph here and really just read off that information about what direction our original graph was going at those places. So I come back and I start off at 0. So at 0, it's telling me I have a positive value. So that's a positive derivative value, which tells me my original graph should be going up at 0. It should be increasing. Then the next value is saying at 1, I have a negative derivative value, which means my graph should be headed down at that place. Then over at 2, I can see I still have a negative derivative value, so my graph should still be headed down. Then at 3, I've got 0 here. So at that point, I should be seeing a horizontal tangent line, something that looks like a max or a min maybe. And then out of here, as this graph leaves the page, as it leaves the graph, it should be headed up. It should be positive and going up and increasing. So as we work through our graphs, I just start over here at 0. And I say, okay, at 0, my graph should be going up. So looking at this graph A is not going up like it's supposed to. So that one gets thrown out. That's not a possibility. Graph B is going up at that point, so that's still good. Graph C is going up, that works. Graph D should be going up, but it's going down, so that one gets thrown out. And then graph E here is headed up, and so that's still on the table. And then we just work our way through these until we narrow it down. So then at 1, my graph should be headed down. So I go over to B, and at 1 right here, my graph is headed down, so that still works. At 1 on this graph, that's also headed down. And at 1 on this graph, it looks like I'm up here at a horizontal when I should be going down. And so graph E is now off the table. We keep working through this. We go to 2 now. When T is 2, we should still be headed down. So looking at B again, still heading down, that's still good. Looking here again at 2, also heading down, so that is also still good. Then I look at X, or at T equals 3. At T equals 3, I should have a horizontal tangent line. And what I see on graph B is my graph is actually going up at that position. And so that can't be my graph. I go over to C, and now I can see down here at 3, I do have that horizontal tangent line that I'm looking at. So C has fit everything I needed. It's the only one left available. But just to make sure, I would come in and I would say, okay, well, at the end of this graph, at 4 is my graph headed up, and sure enough, my graph is still headed up. And so what we can see is in the end, our graph, our original position graph would look like graph C. So this is all about that physics relationship. This time they want us to know that the velocity information is really first derivative data about our original function. And when we read first derivative data, that's telling us the slope of the graph at that specific point. So you just come through your graphs and look for where it's going up, going down, or going horizontal based upon the plus, the minus, and the 0. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.